Hi, this is Richard C. I'm a math tutor at Wyzant answering a question submitted by a student. This is a pretty classic question from Algebra 2. So you should expect to see many more similar questions. This has to do with a rectangular enclosure that has to be built on three sides against a wall. So here's your wall. Here's the enclosure. And that's the length of the enclosure, L. And that's the width of the enclosure, W. And this is your wall. Okay, well, there are 1,000 feet of fencing that they can afford to buy. So the total fencing is 2L plus W. So that has to be less than or equal to 1,000. We'll set it to 1,000. They want to maximize the area, so I think we'll just set it to 1,000. They're going to buy as much fencing as possible to get as much area as possible. And the area, of course, of this enclosure is just length times width. Okay, so this is a nice little system. We're gonna rewrite this one so that W is equal to 1,000 minus 2L, and we'll substitute this. So now the area becomes a function of length because that's the only variable we're gonna have. We'll start with the L, leave that alone, and we'll substitute in the W. Okay, so this is going to be negative 2L squared plus 1,000L. And you should recognize this as a parabola. It's opening down because the leading coefficient is negative, and it's going to start at 0, 0. If we don't buy any fencing, we're not going to have any area. And here's our amount of fencing we're going to put on the length of the enclosure. So it goes through 0, 0, and at some point it's going to come back down to 0. It's going to look something like this. And we're interested in the getting the most area. So obviously we're interested in the vertex here. Okay. So a formula that you should have memorized is that for the vertex, this is a parabola in standard form. The vertex is going to be negative b over 2a. So let's go back and plug that in. So it's going to be negative 1,000 over 2a should be negative 4. So it's going to be 250 feet. So it's going to be 250 here, 250 here, and 500 here because we have 1,000 feet of fencing that we can afford to buy. And that's our answer for the length and the width, the best length and the best width. 250 length, 500 width. And what's the best area? Well, the best area is going to be 250 times 500. So I'll grab my calculator. And I get 125,000 square feet. So that's the the largest area that they can enclose with 1,000 linear feet of fencing, assuming that one side of the enclosure is kept secure by a wall. So that's it. That's all there is to it. There are many different ways to find the vertex here. I just chose the easiest, what I think of as the easiest. You could factor this and find it another way. But basically, you're going to get the same answer regardless of how you do it. But there are many different ways of doing it. This is going to be, you could set the area to 0 and find the 0 here, which would give you 500. So this is going to be 500, and so halfway, the midpoint is going to be 250. That's another way to find it. There's a lot of flexibility in how you're going to solve it. You could also solve it on a calculator, but I think this is the most direct way, and this is a really good formula to remember. It shows up over and over in Algebra 2, and it shows up over and over on the SAT and ACT exams. Okay, so that's it for this question. I hope that was helpful. See you again next time. Bye-bye.